Hello once again, Year 10. I thought it would be useful for me to go through a couple of more challenging histogram questions following your live lesson before half term. The rest of your asynchronous work this week will then focus on completing some histogram questions on Dr. Frost Maths. This is a topic that is very easy to get lots of marks in, and indeed in the exam it is worth lots of marks, but that students conventionally struggle with, and therefore it's pretty much guaranteed this is going to come up. I'm going to look at two past paper exam questions, and I'm also going to add a part of my own to one of the questions so that we can elucidate our understanding a little more. So, looking at the question in front of me, the table shows information about the time in seconds taken for some people to complete a puzzle. You're given a number of times, a number of frequencies with one missing, and you're asked to use the information on the table to complete the histogram, and then use the histogram to complete the table. And you'll notice that the scale on your y-axis, which for a histogram you know, I would hope, is frequency density, is missing. And indeed we know that frequency density is given by your frequency divided by your class width. So if we look at what we know on our histogram, we know 35 to 40 and 40 to 45. So we need to use 35 to 40 to work out our scale. We know that our class width is 5 between 35 and 40. Our frequency is 42. So our frequency density, just added here, is 42 divided by 5, or 8.4. So I know on my histogram that between 35 and 40, this here is 8.4. And so it seems reasonable to assume then that I'm going to have 8 at this line here, but I can just check that. 1, 2, 3, 4, 5, 6, 7, 8.2.4. So I know that each small square is worth 0.2. I could alternatively count up all of the small squares, 10, 20, 30, 40, and then 42, and divide 8.4 by that value to get each small square is 0.2. But regardless, this allows me then to label up my axes so I can continue to draw my histogram. And then that's exactly what I'm asked to do. So I need to work out all of my other frequency densities. My class width is 15 and my frequency is 12. So 12 over 15 is 4 over 5, 0.8. 25 to 35, class width is 10, frequency is 28, so 28 over 10 is 2.8. I can say nothing for between 40 and 45, that's going to be part B of my question. And then 45 to 60, class width is 15, frequency is 9, 9 over 15 is 3/5, or 0.6. And then I just look to transfer that to my graph. I need to use a ruler or a straight edge of some description. I don't have one of those near me, but you certainly should do. And then I need to draw each of my points. So between 10 and 25, I need to be 0.8 high. So between 10 and 25, I need to be between, there you go, I need to have a bar of 0.8. And I could just check the area of that bar, 0.8 multiplied by 15 gives me 12, gives me the value that I needed. Next height is 2.8 between 25 and 35. 2.8 between 25 and 35. Then I don't know anything for 40 and 45, I'm about to do that, but between 45 and 60 I have 0.6. So I find 0.6 between 45 and 60, and I have my final bar. And that's part A complete. Part B asks me to use the histogram to complete the table. Now remembering that my frequency divided by class width is frequency density, if I can work out my frequency density from the histogram, which is very straightforward to do, that is drawn at exactly 6, then I can work out my frequency by multiplying my frequency density by my class width. 6 times 5 is 30. And so I find that I have successfully completed my histogram and my table. And that would be worth 4 marks in an exam. There is one more thing I want to look at doing, however, and that is determining the median from your histogram. Now, you will know that your median is your value which is halfway between your data set. So if we work out our total frequency, I'm going to do that with 12 plus 28 plus 42 plus 30 plus 9 to get 121. That's an odd number, so we want the n plus 1 over 2th data point, or in other words, the 122 over 2, the 61st data point. So, if we look at our frequencies, we first start with 12, so our median is not in this value. And then 12 plus 28 is 40, so our median is not between 25 and 35. But then when I add 42, I get to 82. So my median is between 35 and 40. At this point here, I have 40 data points, and then at 40, I have 82 data points. And I want to find my 61st data point. Well, if I look here, so I want my 61st data point, I want to be 21 data points away from the start of my interval and 21 data points away from the end of my interval. So I can estimate that my median is exactly halfway into this interval. My median is 37.5 seconds. It won't always work out as nicely as that, but we're just saying that the proportion of data points before the 61st data point in this case needs to be equal to the proportion we go into our class width. So more formally, this would be 21 out of 42. How far into this frequency we need to go out of the total frequency? So a halfway in to between 35 and 40. In other words, we're doing 35 plus, and then that's a half in this case, but it could be anything, times 5, because my total class width is 5, and I want to go 21 40 seconds into my class width, giving me 37.5 seconds. So even if these numbers are much more complex, like, I don't know, 16 and then 50, I would just do 35 plus 16 50ths times 5, the class width. Let's look at another example. And this is a slightly strange question. The histogram shows information about the height of some plants. First thing I notice immediately, there's absolutely nothing on my y-axis. Work out an estimate for the proportion of plants over 25 centimetres tall. Explain why your answer to part A is only an estimate. We'll talk about the estimate part at the end. But what I notice here is that there's no mechanism for me to get a scale on my y-axis at all, because normally I would have a table to do so. And that's fine, because the question asks for the proportion, not for an absolute value. So it means, effectively, I just want to know the fraction of the total area that are over 25 centimetres tall. And if I look here, my area that's over 25 centimetres tall is this area plus this area. So what I'm going to do is I'm going to work in terms of number of little squares as my height on my y-axis. There are lots of other things that I could do. I could work in terms of big squares, so it'd be 0.1 per little square. Or I could just pick an arbitrary value y and work in proportions of y. But I'm just going to go with little squares, because it's easy to count, hard to make a mistake. So, work out an estimate for the proportion of plants over 25 centimetres tall. I need to work out the total area, and I need to work out this area here, because I want this area as a fraction of the total area for my proportion. So in order to do that, I'm going to start with the shaded area. This area here, this is 5 centimetres long, and this is in total 12 squares high. So I have 5 times 12, and then plus, this is 3 squares high and 20 squares long. I'm dividing by the total area of the whole thing. So that's 12 squares times a class width of 10, plus, and then we've got 10, 20, 32 squares times a class width of 5. And then we have 44 squares times a class width of 5. And then we have 12 squares times a class width of 10. And then we have 3 squares times a class width of 20. Now, if this were a non-calculator paper, I can work all of these out fairly simply. That's why I've chosen to go in little squares. But we have the luxury of a calculator here, so why not use it? So I'm going to set up my fraction, 5 times 12 plus 3 times 20, and then dividing by 12 times 10 plus 32 times 5, apologies, plus 44 times 5, plus 12 times 10, plus 3 times 20. And of course, to make that a little bit quicker for yourself, you could always simplify the ones that you can do in your head very easily. Giving me, in total, 3 over 17. So the proportion of plants over 25 centimetres tall is estimated to be 3 over 17. Now, the reason this is an estimate is because I've cut this bar in half, and I've assumed that of my plants between 20 and 30 centimetres, a half of them are between 20 and 25, and a half of them are between 25 and 30. But that doesn't have to be true. It could be the case that all of these, everything represented by this area, are all 21 centimetres tall, or all 29 centimetres tall. We don't know. So this is an estimate because we are assuming that data points are evenly distributed. And specifically, we're assuming they're evenly distributed, in this case, in the range between 20 and 30 centimetres. It might be easier to see that by looking at this here. We know that there are 12 times between 10 and 25 seconds. That could be 12 times all of 11 seconds. Or it could be 12 times all of 24 seconds. But we're assuming when we've drawn the bar that there's an equal likelihood of being above and below the midpoint of that interval, 17.5 seconds. So we're assuming in a histogram that there's an even chance of being spread throughout our interval. And that's why things are estimates. I hope that was helpful. You've also had a lot of instruction from your teachers. You can, of course, ask for help. And the Dr. Frost will also provide some videos to help you should you feel you need it. Good luck.